Bismillahirrahmanirrahim. In today's video, we discuss about the discontinuous conduction mode. First of all, what is mean by discontinuous induction mode? So we also say it that what is the first we discuss the discontinuous conduction mode, difference between discontinuous conduction mode and continuous conduction mode. So also called CCM and DCM. So what is the difference between these two? In CCM, the current ripple or the voltage, capacitor voltage or inductor ripple is such like this is the DC average current and this is the ripple. So the upper side is del I, the lower side is also equal to del I, so the whole is equal to del I. So this is the continuous conduction mode of inductor current ripple and capacitor voltage ripple. Now what is mean by DCM? In case of DCM, we use the unidirectional switches. Unidirectional switches like diode, etc. In this, it is called unidirectional switch because the current just flow in this direction, while in this direction current is equal to 0. So when we use this, so in discontinuous conduction mode, we get such type of inductor current ripple and capacitor voltage ripple. This is, let's about DTS. So this is will be D2TS, this will be D3TS, and up to this it is equal to TS, and here up to this it is equal to TS. So now how this happen? So we come toward this discontinuous conduction mode just occur in DC-DC converter. It probably sometime also occur in inverters, etc. In discontinuous conduction mode, the properties get changes. How? For example, in continuous conduction mode or conversion ratio does just depend upon D. Now here the conversion ratio also depend on load. It also depend on load. If you increase the load, then such type of DCM occur in such a way that the current get reversed, but the switches doesn't allow that reverse current, so that's why the current becomes 0. And in DCM, the inductor current ripple and capacitor voltage ripple is large enough than the DC current flowing in inductor or in capacitor. Now it operate in similar to the CCM in steady state. In steady state, it operates similarly as in CCM, but in transient state it operates literally different from CCM, and we apply in this method. We also apply the same method as we applied in CCM or second balance and MPS second balance. These two will be same as in CCM, but care must be, you must care in inductor current ripple or capacitor voltage ripple? Because here the ripple is so large. So applying of small ripple approximation doesn't work here. Does not work here because here the ripple is very large enough. The current is this type and the ripple is too large in DCM as the current ripple is larger than DC current. So we due to which we unable to apply small ripple approximation, and we will see when we do derivation. So this is all about the introduction to the discontinuous conduction mode. So now in next video we discuss about the origin of the discontinuous conduction mode and mode boundaries. So subscribe our channel and for further and see our further videos. Thank you.